This first one, where's my red light? Where's my red light? Oh, where's my red light? There it is. It's back. This first one, of course, now some kids in the other class like Mr. Myers, no such thing as a negative square root. But that's not what this is asking, is it? No, because the negative is outside the brackets. So that is negative 14. Does 27 have a square root? It's not on our list, but it's only a little bit more than 5, right? So 5.1. This is the first one where you had to do some thinking. If there was no fraction there, what would the square root of 9 be? 3. If there was no 9 there, what would the square root of 100 be? 10. So, is 3/10 the square root of that? The only way you can check is by remembering that a square root means if you multiply it by itself, you get this answer, right? Well, what's 3 times 3? 9. What's 10 times 10? 100. Everybody good? I didn't show you that specifically, but we all know that if an exponent has brackets, you apply the exponent to everything. We all know that square roots have something to do with squaring, and we can all quite plainly see that this symbol encompasses the whole of that fraction, yes? Oh, that sounds weird. The whole of that fraction. Ooh, math puns. This one. Is this a perfect square up top? Yeah. Is it a perfect square on the bottom? No. So you had to estimate this. This is very close to 225 over 49, isn't it? Which would be 15 over 7, wouldn't it? So this must be pretty close to 15 over 7. Is everybody picking up the thinking that goes into these? Good. This one bothered quite a few people in the other class because they were like, because I said no calculators. 25 is easy. What's the square root of 25? 5, right? Okay, but that's not 25, is it? It's 25 over 100, right? So, square root of 25 is 5, square root of 100 is 10, but you would never hand that fraction in to Mrs. Bad Crumble. It's 1/2, or 0.5. No. Because 0.5 times 0.5 is 25 with 2 decimal places. 1, 2, 0.25. Also, 1/2 times 1/2 is 1/4. 1 times 1 is 1, 2 times 2 is 4, and 1/4 is 0.25. This one is, of course, what? 1/5. This one is, of course, 0. This one is around 6.7, sure. This one is around negative 6.7. Everybody remembers how to find that? That's what we talked about yesterday. This is, of course, 11. This one, a lot of people in the other class said was irrational. Is it? 5 doesn't have a square root. 20 doesn't have a square root, so it must be irrational, right? Except 5 over 20 is not a fraction you would ever send back to Mrs. Bad Crumble, is it? What is that really? 1/4. And don't we know that the square root of 1/4 is 1/2 because we already did it? So this one was 1/2. And this one had to be what? A little bit less than what? A little bit less than 3 because the square root of 9 is 3. So this would have had to be 2.9 would be a fine estimate. Everybody good? Can everybody do this page? Excellent. Then, on the next page, I was nice. I said, get out your calculators. If it was irrational, all you had to do was write irrational. Was that one rational or irrational? Irrational. You didn't even need your calculator because you looked on your list that we made yesterday and you saw 576 was nowhere on the cube list, was it? So it couldn't be rational. You get your calculator for that. Does that have a square root? When you got out your calculator? No, so it was irrational. Now we get to this. This is the first one that I wanted to talk about because this, after you use your calculator, it should, hopefully, you should have said, oh, that's interesting. Maybe there's something more there. When you did that with your calculator, what'd you get? 30, correct? Now, look closely. If there were no zeros there, what's the cube root of 27? 3. Everyone agree? 3. If there was no 27 there, then that is 1,000, isn't it? What's the cube root of 1,000? 10, right? We did that on our list. Now, so that means under this radical sign is really 27 times 1,000, isn't it? And the cube root of 27 was 3, and the cube root of 1,000 was 10. What is the relationship between 3 and 10 and 30? 3 times 10 is 30, just like 27 times 1,000 is 27,000. Does everybody see that handy-dandy little piece of math? Excellent. You did that in your calculator, and I believe you get 15. You did that on your calculator, and I believe you got 270. Yeah? Because isn't that 729 times 100? That's 10. Square root of 729 is 27. So if that times that is that, then the square root of it must be that times that. Everybody cool? Now all of you should be noticing twice now we have been able to do something to the number that lives under the radical sign. What did we do in both cases? Or you used your calculator, but I showed you what it meant. What did we get to do to both those numbers? We broke them down into smaller numbers that we could work with, yes? Please keep that near the front of your brain, somewhere in your prefrontal cortex. This, of course, is irrational. Even though it looks like it should work, doesn't it? But that's 100,000, right? Which is 100 times 1,000. 100 has a square root, but 1,000 doesn't. So that makes that irrational. This one, I can't remember. 12, that one worked. This one, 23. This one, 10. This one, if there was no 225 there, what would it be? What's the square root of 196? We've already done it today. 14. If there was no 196 there, what would the square root of that be? 15. So it's 14 over 15. That one have a square root? Oops. That's irrational. That one have a cube root? Yep, it's on our list, 4. This one messed up a lot of people in the other class. Because isn't that 125 over 1,000? What's the square cube root of 125? It's on our list, 5. What's the cube root of 1,000? 10. 5 over 10 is 1/2 or 0.5. What's the cube root of 125? 5. What's the cube root of 27? 3. Done. And this one, irrational. Is everybody good with those 2 pages and the extra piece of information that gave us, that we're allowed to break those big numbers up? Everybody's cool? All right, now, I can't remember if I asked you to do 94 or 95 or not. Did I? I didn't? Good. I want you to look at that right now and see if you can figure it out. Go. If I have a cube and the sides are 15, what does the front of that cube look like? What shape is that if it's a cube? Square, which means the sides are both 15, yes? Which means how big in surface area is the front of that cube? 225, yeah? How many sides are there in a cube? 6. So what do I got to do with 225 to find the surface area of a cube? Times by 6. 6 times 225 is 1350. Right? Excellent. Now, that's review from Unit 1. You all should be able to do that in your sleep. Now, let's talk about this one. What's the surface area when I know the volume? Well, if it's the volume of a cube, what do I know about the length, the width, and the height? They're all the same. What else do I know? That length times width times height equals volume, correct? But I do not need 3 variables, do I? How many variables do I need? 1. S squared cubed equals volume, correct? Do I know the volume? What is it? 216. So S cubed must equal 216, yes? So what does S equal? The cube root of 216, which is 6. It's right on our list, right? Okay, so that means this is 6. So what's the surface area? What's this surface area? 36. How many of them are there? 6. So the surface area is S squared times 6, isn't it? 6 times 36 is 216. 216 watts, because that is not the same number, is it? Centimeters squared. Everybody good? All right. Now, the last thing I asked you to do was the right-hand side of this page. These first 3 questions were super easy, weren't they? What's this one? 22. What's this one? 43? 42. That's what I thought. What's this one? 18. What's this one? 25. This is what we just did, yes? What do I have to do to that to find the side length? That's the whole surface area. What should I do to find one side? No. Nope. Wow. How many sides are there on a cube? 6. That's all of the cube. I need one face of the cube. So what do I do? Divide by 6 to get what? 1,000. He waited patiently for everybody to get out their calculator and do it now because they didn't do it for homework. 1,089. Then what did they do? You square root that to get what? 33. Now what's the volume? If that's one side, what do I do with one side to find a volume? Find a volume. Cube it. So it was 33 cubed, which is whatever that is. It's a giant number. 35,937. Now, did anybody attempt this for 10 gummies? Remember, the answer was sitting right there. So to get the 10 gummies, you had to show me how that answer was gotten. Did anybody even attempt it? Oh, that makes me sad. You shouldn't have. You're a smart guy. Okay. There's a square, yeah? What's the area of that? X squared. How many of them are there? 4. Everyone agree? Okay. What is that area? Length times width, which is x times 5x over 8, correct? Okay. So what's x times 5x? No. This is the exponents page. You just did 2 pages of this work. 5x squared over 8, correct? How many of those roof pieces are there? Times 2, so that would be 10x squared over 8, correct? Everybody agree? So 4x squared and 10x squared, right? So the only thing that's left is this triangle, right? I'm going to make that a little bigger so we can work with it, because this one is tricky. This is x, correct? This is 5x over 8, correct? How do I find the area of a triangle? Base times height divided by 2, yeah? So if I know this height, I can find the area of this triangle, yeah? Is your hand up, Haram? Or are you just stretching? What? Yes, I'm about to get to that. Then do you do Pythagoras? Yeah. So, I need this height, correct? Which means I have now built a 90-degree triangle, right? Haram has told us that this side right here is x over 2, isn't it? Now, do I have a mathematical tool that will find me this side? Pythagoras, right? Adding or subtracting? Subtracting. If I square that, 5x over 8 squared, and I subtract x over 2 squared, and I take the square root, will I have this side? I will, won't I? Yeah, but let's work it through, right, Haram? You're exactly right. What is 5x over 8 squared? 25x squared over 64, yes? We already know that from our exponent unit, right? Minus x squared over 4. We still cool? And all that is square rooted. We're still good, right? Can I do this subtraction right now? Hey, Indigo. Can I do this subtraction right now? No. So you should pay attention because that's grade 4 work. I would stop talking. Okay? Because very soon there is going to be a major shakeup to the seating arrangement in this room. I'm going to move you 4 to a back corner so I can't hear you not paying attention to me. Because it pisses me off. Okay? If you don't want to pay attention, put in your earphones like half the rest of the class and listen to music and ignore me. Until marks come out and then you can yell and complain about how you're getting bad grades. Okay? Okay. I cannot put these together right now. Why? Lennon. Nope. Karen. It is, of course, because they do not have the same denominator. The denominator I need is 64. So 25x squared does not change. What did I have to do to that? Multiplied it by what? 16. So what do I got to multiply that by? 16. So now I got 16x squared. I got 25x squareds and I'm taking away 16x squareds. What's that? 9x squareds over 64, yeah? Now I square root it. What's the square root of 9x squared? 3x. Square root of x squared is x. What's square root of 64? 8. So that is the height. Now, the whole base was what? What was the whole base? X. What was the height? 3x over 8, yes? And that's base times height, but I'm supposed to divide it by 2, aren't I? Divided by 2, but aren't there 2 triangles? One at the front, one at the back? So I would have to multiply that by 2, wouldn't I? So what happens to the 2 and the 2? They're gone. So I have, what is x times 3x? No. 3x squared over 8. And that covers this triangle here and the back, right? So now I got this, this and 3x squared over 8. What do I need to do with all three of those? Add them up. Can I add them up? No, why not? I don't have the same denominator. What is the denominator? 8, 8. What's the denominator here? What? 1. What do I need to do to that to make it 8? Multiply it by 8. What is 4x squared times 8? 32x squared plus 10x squared plus 3x squared over 8. 32 plus 10 is 42. 42 plus 3 is 45x squared over 8. Now, all of you should say, Mr. Myers, that's a stupid question. And I 110% agree. That's an idiotic question because you, of course, would never get the measurements of a room or a wall or anything that way, would you? Ever. But, do you need to know how to square things? Yes. Do you need to know how to deal with exponents? Yes. Do you need to know how to square root things? Yes. And what is the only thing we did in that question? Exponents, square roots, and added fractions. Was anything in that question new? No. Some of you will say, I do not need to know this, and I agree with you 110%. If you are not planning to go on to any kind of post-secondary education, that is a useless question. If you are planning to go to any kind of post-secondary education, and I include you want to be an electrician, you want to be a plumber, you want to be a heart surgeon, you got to know how to do this. Not because you're going to do it when you're a plumber, heart surgeon, or electrician, but because the people that run those schools only want the people in there that have the powers to figure out questions like this. So yes, it holds no real-life application for you, except that they use whether or not you can do questions like this to decide if you are going to go to the schools or the courses that you wish to attend. Okay? Which is part of the reason why I get so angry when I hear, when am I going to use this in real life? Everybody good? Sweet. Take a nice deep breath. And then we move on to page 96 in a moment after you have had a second to gather your thoughts. All right. What we are going to start today is the beginning of the end of your calculator usage. Yes. Rapid detox for all of you because you are addicted to your calculators because you reach for them when I ask you to do 7 times 4. You laugh, Nick, because you know it is true. Yeah. Up until right now, if I showed you this, you would put that into your calculator and tell me the answer was 7 point blah. Right? All of you would. Some of you are twitchily reaching for your calculator right now as we speak. You will never do that again unless you are in a physics class or finding a real-life answer to a physics question. From now on, what I'm going to show you today is what you are going to do when you are faced with any kind of irrational square root. Okay? But before we do that, we need to talk a little bit about the terminology that will be in play this section. A radical is any expression containing that symbol. You call that the square root symbol. But as you have realized over the last few days, it is not always a square root, is it? It can be a cubed root. It can be a fourth root, and so on and so on and so on, up to the x root. This little number, I have told you what its name is. It is the index. And it tells you the size of root you need. If it is a square root, you are going to get the answer will be 2 of the same number. For example, the square root of 9 is 3 times 3, so it is 3. If it is a cube root, how many will be here? 3 of them. It will be x, x, x. 3 times 3 times 3, which is 27. If it's a 4th root, how many will there be? 4 of them. X, 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 x. 3 times 3 is 9, times 3 is 27, times 3 is 81. So the 4th root of 81 is 3. The cubed root of 27 is 3. Everybody cool with that part of the terminology? Excellent. Now, we are going to highlight 2 things here. An entire radical is just index, symbol, and some expression underneath. That expression could be a single number. It could be a variable. It could be a coefficient and a variable. It could be a coefficient and a variable with exponents. It can be any mathy thing. Everybody cool? This thing right here is called the radicand. And the radicand can be anything mathy. Everybody good? Okay. Now, just like fractions, a mixed radical has 2 parts to it. It still has the x index and the y radicand, but it also has a coefficient. And what is the function of a coefficient? What math does it do? It multiplies, right? Just like if I had 3x, that means 3 times x. So this means whatever a is times that radical. Is everybody good? This is your new goal when you are faced with a question like that. You are going to turn that into one of these. Is everybody good? Okay. Some of you already know how to do this. If you do, I apologize. I'm sorry. But if you don't, no big deal. Or if you do, you're just going to deal with it. Now, so we're going to do this right now. Root 72. Is 72 on our list of perfect squares? No. So until today, you all would have gone square root 72 on your calculator and gotten 8.48, blah, blah, blah. Just like we did yesterday when we tried when we estimated the square root of 72, right? We are not doing that anymore. Here is what we are going to do. Now, remember, on the previous page, we could take our radicands and break them up smaller, couldn't we? Right? We took 27,000 and broke it down into 27 and 1,000 because they both had a cube root, right? Okay. What kind of root am I asking for here? Cubed, squared, 4th, what? I'm asking for a square root, right? Which means I want from under here anything that has 2 equal factors, right? But we know there isn't one, is there? But we're allowed to break this down into something smaller. Now, I have been doing math significantly longer than you. So when I see this, I do not see the square root of 72 because I know the square root of 72 does not exist, right? What I see, and I'm going to write down what I see, and then I want one of you to tell me if you understand why I wrote that down. I do not see the square root of 72. I see the square root of 36 times 2. Why? Jovan? Because 36 has a square root. Everybody agree? Okay, so if there was no 2 there, what would the answer to this be? 6, because I would bring a 6 out from under there, and the answer would be 6, yes? But there is a 2 there. So I can get out the square root of 6, but I couldn't get out the square root of 2 because it doesn't exist, does it? So I had to leave it under there. Under there. Does everybody see what happened there?
Yes.
This, my fault. I set myself up for that one. Touché. This is what I can do because I have done this a bazillion, cajillion times. Okay? This is like the expert method of what we're doing right now. But let's pretend you don't have as quick access to the perfect squares as I do. We can still break this down. Okay? If you were going to break down 72 to two numbers that multiplied together, what would you use? Any two factors of 72. 8 times 9. I heard somebody say it. I'm going to do these in blue because this is kind of the middle level. 72 is also 8 times 9, isn't it? Okay. 9, hey, wait a minute. Isn't that a perfect square? What's the square root of 9? So what would come out here? 3. Excellent. And I left an 8 under there. Right? 8 doesn't have a perfect square, does it? But can we break 8 down? Into what? 4 and 2. So isn't this the same as the square root of 4 times 2? Why did I choose 4 and 2? What's special about 4? It's got a square root. What is it? 2. So what's coming out? 2. But what's already out? So now I have a 2 and a 3 in the coefficient spot. What do coefficients do? Multiply. So what's 2 times 3? 6. And what did I leave under there? 2. Everybody see what's happening here? Everybody? Now let's pretend this is still blowing your mind. Which some of you are going to be like, ah. We can do a third thing that will always work but requires more math. So if you want to use it, you're welcome to. Continue to break 72 down. Break it down any way you want in a factor tree. 8 and 9, 2 and 4, 2 and 2. Agreed? 3 and 3. Yes? So 72, the square root of 72, is also 2 times 2 times 2 times 3 times 3. Correct? I'm looking for square roots, yes? Which means I need groups of how many factors? Groups of 2. Is there a group of 2? So out comes a 2. Is there a group of 2? So out comes a 3. 3 and a 2 in the coefficient spot. What do I get? 6. And what did I leave under there? 2. Do I care which method you use? Why? Because you get the same answer. The more you practice, the more often you will do the red version. The less you practice, the more often you are going to have to do the green version. Which one allows for more chances of a possible mistake? The green version. Everybody with me? All right, let's start applying this now. Is 99 on my perfect square list? Of course not. So I need to break it down. Can any of you see a perfect square that will divide into 99? Karen? 9. Because 99 is 9 times 11, correct? Does 9 have a square root? What is it? So what comes out? 3. What stayed under there? 11. Expert way. She saw it right away. What if you didn't? Well, then you might have to do this. Well, 99 is 3 times 33. Still nothing. 3 times 3 times 11. Oh, there's my pair. Out comes a 3, and I left an 11 under there. I still don't see it, Mr. Myers. Okay, 99 breaks down. 3, 33, 3, 11. There's my pair. 3 comes out, 11 stays under. Any problem? Super easy, right? And then, 1 second, Aram, what do I get to avoid from you people every time I write an answer? What is the one thing that is not being said? Because if I gave you this answer, square root of 99, it's 9.99. Blah, 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 blah. If I write that out, half of the class is going to say, is it okay if I put it to 9.93? And the rest of the class is going to say, well, it's really 9.3937. Do I have to deal with that now? No, because how many right answers are there? 1. No rounding, no horse crap. Haram, go. No rounding, no horse crap, 1 answer. That's what I want. That is what you will do for the rest of your math careers. Okay? So, here's B. Should I use the red, blue, or green? What do you like? Can I know what you like? No, because I can't read your mind. You know what you like. Which one do you want to do there? You want to do the blue one? Okay. So if I were doing the blue one, I would go what? 5 times 15. Still no squares, right? 5 times 5 times 3. Is there a pair? What is it? So what comes out? 5. What stayed under there? Now, if I was an expert, I would say, isn't that 25 times 3? What's square root of 25? 5. 5 root 3. I'm not comfortable with this, Mr. Myers. I need to see it. I'm a visual learner. I got to see what's going on. Great. 75. Break it down any way you want. 5, 5. There's your pair. What comes out? 5. What stayed under? 3. Can everybody do this? Awesome. Possums. What are you going to do with 80? You're going to use 40 and 2? No problem. So you'd be doing the blue. Do you like the blue or the green? Because they both start the same way, don't they? We break it down into factors. Do you need the blue or the green? You're going to go blue. So Javon is going 40 and 2. Any perfect squares there? Nope. So what should he break the next one down into? 2 doesn't break down, so where's he got to go? 20 and 2. Okay, 20 times 2 times 2. Hey, what do we got there? There's a pair. 2's coming out. Does 20 break down? What does 20 break into? 2 times 10. No pairs there. What does 10 break down into? 2 times 5. What's that? Pair. What comes out? What's already out there? What do they do? Multiply. What did I leave under there? 5. Now, I know that 16 times 5 is 80 because I've done more math than you guys. So I only need to do one step, don't I? What's square root of 16? 4. 4 comes out, leaves a 5 under there. Please notice, the bigger the number, the more likely you might have to go to the green version, right? But you don't ever need to. Everybody cool? Now, let me ask you this. What if I was doing the green version and I said to myself, self, that ends in 0. So I could use 10. But what if you used 5? Then you would get 16 and 5, wouldn't you? And right there you could stop, couldn't you? Because you know that has a square root. And that 5 isn't going to match up with anything. So after you've practiced this a little bit, even if you're doing the green line, any branch that ends at a perfect square, you could stop at that, couldn't you? Because that's what's coming out. Is everybody good? Great. Look at D. What are you going to do? It's a big number. What are you going to break it down into? 3 and 100. So can we do the red one here? Yeah, of course we can, because it's 3 times 100, right? Right? What's the square root of 100? So what's coming out? What do we leave under there? 3. Everybody cool? Can I just leave it as the red one? Is everybody okay with that? Okay, what about E? Is there a perfect square that I can bust out a 63? 7 times 9. Does 9 have a square root? What is it? So what comes out? What stayed under there? But notice everybody in the class didn't immediately say 7 times 9, did they? So some people in the class would have been either doing the blue method or the green method. If they did the green method, almost all of you would go 9 times 7, because that's the one that you're comfortable with, because it's in the 1 to 12s, right? And you could stop right there, because that's a perfect square. Square root of 9, 3. And that 7 is prime, so we would have stopped there anyway. Everybody good? Great. Try 32. What is it? How many of you went 8 times 4? Be honest. Nothing wrong with that. 8 times 4. Can I stop at the 4? Why? Perfect square. So what's coming out? 2. 2 root 8. Can't stop at 8 though. What's 8? 4 times 2. Can I stop there? Yeah, but I can stop there because I'm going to bring a 2 out, right? Because that's a perfect square. What did the 2 and 2 do? 4. And what did I leave under there? 2. What if I was an expert and I noticed right away that that is 16 times 2? What's the square root of 16? 4. What did I leave under there? Okay, now do G by yourself. It's the biggest one. Go. Oh, I'm almost out of coffee. What is it? Jovan. Yeah, it's 3 times 121 because you're an expert almost already. What do I do now? Square root 121, which is 11 root 3. Mr. Myers, there is no way I would have caught that. Okay, so you break it down. 363 obviously divides by 3, doesn't it? 3 goes into 3 once, goes into 6 twice, goes into 3 once. And maybe you still don't see, oh, that's a perfect square. So you break it down to 11 and 11. There's your pair, out it comes. And you make a wish at 11:11. I like that band a lot. If you don't like that band, you have bad taste, but that's okay. No, the band is Arkells. The song is 11:11. You made a wish at 11:11. I held your hand at 12:34. There was a kiss just waiting to happen. A cab was coming outside the door. Super famous band. Like, big deal. Like, 20,000 people go see their shows. Nothing? Oh, well. Can everybody do this? Excellent. Turn the page over. What's different in number 2? We've already done the work, haven't we? So I want you to reverse it. If there's 1 2 out there, how many 2s had to be under there? 2. What's 5 times 2 times 2? 20. If there's 1 7 out there, how many 7s were under there? So it's 29 times 7 squared, which is 29 times 49, which is 1,421.
Yeah, I got that too.
How are you doing this?
If there's a 2 out there, there had to be 2 2s under there, so they could have come out. Well, there's already a 5 under there. So 5 times 2 is 20. If there's already a 6 out there, how many 6s had to be underneath? 2. So that would be the root of 4 times 6 squared, which is the root of 4 times 36, which is the root of 144. It is 12. Here's why. I'm glad you caught that. It's there on purpose. What's the square root of 4? So what would come out? 2. Was anything left under there? What's 2 times 6? 12. So 6 root 4 is 12. So is the root of 144. Okay? What's weird about D? There's a negative. What is the coefficient? Is it negative 5 or is it negative 1 times positive 5? It's negative 1 times positive 5, isn't it? So that is all that goes back there. So it would be 12 times 5 squared, right? Which would be 12 times 25, which would be 300. But I can't forget the negative out front. It's exactly like the negatives with exponents, isn't it? Right? Remember, this is negative 4, but this is positive 4. Everybody remember? Okay, now you know everything there is to know about simplifying radicals. So let's start applying it. What's weird about 3a? There's a little 3 in the index spot, which means, am I looking for groups of 2 or groups of 3 now? Groups of 3. Now, if you were an expert and it was square root, you looked for perfect squares, yes? Well, now it's a cube root. So if I'm an expert, what am I looking for? Perfect cubes. Is there a perfect cube that works with 54? Yeah, look at your list. What's the first perfect cube? 8. 8 doesn't work with 54. What's the next perfect cube? 27. Does 27 work with 54? Yeah, because isn't 54 27 times 2? And what is the cube root of 27? 3. So what comes out? 3. What stayed in? 2. Cube roots are harder, aren't they? Maybe you don't know them. But fortunately, you have the green and the blue method available to you as well, don't you? The blue method, most of you would probably say, my guess, would be 9 times 6, right? Is that what most of you would say for 54? Okay. No groups of 3 there. They're not even the same. What does 9 become? 3 times 3. What does 6 become? 3 times 2. What do you see right there? A group of 3. So what comes out? 3. And what stayed under there? 2. What if I want to do the green method? Because this bothers me. I like the branches. I need the branches. Okay. 54. 9, 6, 3, 3, 3, 2. What do you see right there? Group of 3. Who decides? Who decides? You decide. How many of you think you are always going to use one method? How many of you think I always use one method? Good, because if I wanted, for example, the cube root of 6,384, you think I can do that like this? Oh, that's nice of you to think that. I wouldn't have a hope in halibut of doing that in the red version. I would have to do the green version there. But then I will mix it up a little. If somewhere on my green factor tree I come to a perfect cube, would I stop that branch? Yes. Everybody good? So what are we doing for B? You're going to go 12 times 12. Got to do the blue method, right? Because 144 doesn't have a cube. 12 times 12. Damn, that's only a pair. I need 3. So I break down again, right? What do you want to break them down into? Okay. 6 times 2 and 6 times 2. Any groups of 3? Still none. Break it down again. What's 6 break to? 3 times 2 times 2, right? And that 6 is 3 times 2 times 2. Is there a group of 3 somewhere? 1, 2, 3. So what comes out? 2. Cube root. What stayed under there? 3 times 3 times 2, which is 18. Is everybody good? All you're doing is the factor trees that you learned in what grade? 4 or 5. And then you have to count. Are you ever in doubt of what you have to count to, or does the question tell you every time? Question tells you every time. All you got to do is be able to count. What are you going to break 128 to? You want to go 8 and 16? No problem. 8 and 16. But I need a bigger group this time, don't I? What group do I need? 4. Okay. Well, 8 is going to be 2 times 2 times 2, isn't it? I've skipped a step there, right? Because I know I need 4, and I know 8 is 2 times 2 times 2. So I'm just going to write them out that way. What about 16? It's 4 times 4, isn't it? Well, isn't that just 2 times 2 and 2 times 2?
But if you did it the other way, like 8 and then you did 4 and then you did 16, which is 4 times 4, wouldn't you have?
Doesn't 16 have a 4th root? Because it's 4 times 4, which is 2 times 2, 2 times 2, isn't it? That's what I'm about to say. So now I have 1, 2, 3, 4, 5, 6, 7 2s, yes? How many do I need? 4. So I bring out one group of 4, and what did I leave under there? 2 times 2 times 2, which is 8. Now, Javon just stole my thunder because I was going to say, hey, wait a minute. Isn't that 4 times 4, which is 2 times 2, 2 times 2? If I notice that has a 4th root, could I have stopped right there? Yes, because I could have brought the 2 out there, and I would have left the 8. Is everybody good? Yeah? Everyone's good? Okay. I don't think you're lying yet. We're going to do D, E, and F together, and then I'm going to shut up, and then you're going to have to prove it. What's weird about D? It's another 4th root, right? So how big a group do I need, Marcos? 4. Okay, so let's bust it down. It ends in 2, so what should I divide it by? 2 times what? 81. I get to stop there. Why? Because 81 is 3 to the 4th, isn't it? 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So I recognize that and stop right there because the answer becomes 3 4th root 2. This would have been the red one, right? Because I would have done this right away. Hayden saw this. Did anybody else? So we break it down again, don't we? 2, 9 times 9. Now, some of you might see it here. You might stop here, right? Because here you might say, oh, 3 times 3, 3 times 3. There's my group. But if you don't, what do you got to do? You just keep breaking it down and making it simpler. 2 times 3 times 3 times 3 times 3. Oh, there's my group of 4. Silly me. Right? Now, the next question is going to allow you to do something that you guys are really, really bad at. And what I mean by that is you look at every question like it's something new. You forget something you did 2 minutes ago, right? 2 minutes ago, we did the cube root of 54, didn't we? And it was 27 and 2, yes? Does 54 and 108 share anything? What? Right. Isn't that 54 by 2? And don't we already know that 54 is 27 by 2 by 2? So I can stop now, can't I? Right? How many of you, and please don't take this as a criticism, how many of you, without me, think you would have caught that considering we just did it? Probably not too many, right? Because you guys look at every question as being something new. That's why you'll say, hey, Mr. Mars, I don't know how to do 6A, and I'll help you with 6A. And then 6B, you say, hey, Mr. Mars, I don't know how to do 6B. Is 6B ever any different than 6A? No, it's just got different numbers. Is the math change? No. Learn and keep in your head what you need to know. So this is, of course, what's cube root of 27? 3. And what did I leave under there? 4. And square root of 108. What is it? What are you going to use there? You're going to do probably 2 and 54 again, because we just did 2 and 54, right? We've already done square root of 54, haven't we? Haven't we? 9 times 6. Can I get that out now? What would it be? 3. And I left 2 and 6 under there. What does 6 become? 2 times 3. Is there a pair? So what comes out? The 2. What's already out there? What do I do with those? 6 root. What do I leave under there? I left a 3. Is everybody cool? All right, now listen to me. You now have all the information you need to do the following work. Page 98. Page 99. Now listen, on page 100, I'm going to give you guys some new responsibility. We're halfway through the year. I'm trusting you more now. Please notice that on page 100, there is crap tons of work, yes? But it's just like what I just told you, isn't it? 6A, 4A, B, C, D, E, F, G, H are all exactly the same, aren't they? The numbers are different, but you're going to use the same math, correct? So let's say you do A and B, you check the answers right down here, and you've done them perfectly. Do you need to do C, D, E, F, G, H? No. Should you try one of the last ones? Because they're usually where the harder ones are. If you could do A, B, and G, can you do C, D, E, F, and H? Yes. Who needs to make that decision? You. Now, some of you are going to take this as a license to never do any more of these pages. And that's fine with me, because I am not going to your house and making you do this. But when you get back your tests from me, covered in X's and question marks, and you have done none of this practice, what will I say? Tough luck. Got it? You are big enough now to be responsible. The operative word there is responsible on both sides. If you don't practice, you're responsible for what you get. If you do practice, you're responsible for what you get. Okay? Now, further to that, let's say you do a few on the left here, you're okay. Then I recommend, if you get to the point where like, you know what, all this stuff's easy, I recommend you try one or two of the higher numbers, not just the end letters. And if you can do those, you're most likely good with this page's concept. Okay? I recognize that a great many of you feel you do not have enough time in your day to get the meager amount of work I assign you done. So, I am allowing you to have less. But I'm putting the responsibility upon you. Alright? Because I'm tired of doing homework checks and giving a bunch of X minuses. There's no point. I will still do homework checks because I still need proof of who is doing at least some practice. But I am no longer going to say, do this whole page, because it's just not getting done by 90% of my students. So work till you're good. If you don't, accept what you get. Deal? Go.